Question 1a. Excess nitric acid is added to solid calcium carbonate. Determine the products and write a balanced equation for the reaction. To start our equation, I'm going to write down the reactants: nitric acid, HNO3, and calcium carbonate, CaCO3. The first thing I'm going to do is figure out the states of each of these. Nitric acid is an acid, so we know that it must be aqueous. Calcium carbonate is solid. We can tell this from context clues. The question lists it as solid. The second thing I'm going to do is determine what type of reaction it is. It could be combustion, synthesis, decomposition, single replacement, double replacement, or acid-base. It cannot be a combustion reaction because the reactants include neither a hydrocarbon nor oxygen gas. It is also very unlikely that nitric acid and calcium carbonate will come together to form a single molecule, so we can rule out synthesis. The reaction wouldn't be decomposition because there is more than one reactant, and we can rule out single replacement because there are 4 ions. This leaves double replacement and acid-base reactions. Only one of these can work, so by referencing the activity series, we can figure out if double replacement would or would not work. Because we have nitric acid and calcium carbonate in a double replacement reaction, the anions would switch, so you'd end up with hydrogen carbonate and calcium nitrate. But calcium is higher on the activity series than hydrogen, so the carbonate would not want to switch, meaning that it cannot be a double replacement reaction, and is therefore an acid-base reaction. Since it is an acid-base reaction, that now means we have to find an acid, base, conjugate acid, and conjugate base. Starting with nitric acid, that's an acid. Not only does it say it in the name, but the hydrogen would separate from the nitrate and be taken by the base. That means that calcium carbonate is our base. It also means that nitrate is one of our products. Now, carbonate, CO3, will always turn into CO2. More on that later, but that also means that carbon dioxide will be another one of our products. This leaves us with hydrogen and calcium oxide. Now, these products would work fine if it weren't an acid-base reaction, but calcium oxide will not take a hydrogen cation. So we can break it into calcium and oxygen. Hydrogen and calcium will not go together since they are both cations. One hydrogen and oxygen will also not go together because that would form hydroxide, which is a base. But we can add 2 hydrogen and make water, which is a base. Next, I'm going to find the states of our products. Carbon dioxide would be a gas. This is because the molecule is very light and is nonpolar. It only experiences dispersion and stays to itself, so it cannot gain enough mass and or weight to become solid. Water is a liquid. There is already water in this reaction from the acid, so we can add more. Calcium is an alkaline earth metal, which mimic the properties of metal, meaning it has a very high melting point. In this case, it would be solid, since the reaction was most likely performed at room temperature. Nitrate will be aqueous as it is soluble and it is just the ion. The last thing to do is balance the equation. On the reactant side, we have 1 hydrogen atom, 1 nitrate ion, 3 oxygen, 1 calcium atom, and 1 carbon atom. On the product side, we have 2 hydrogen, 1 nitrate ion, 3 oxygen atoms, 1 calcium atom, and 1 carbon atom. Now, the hydrogens do not add up, so we need to balance that. To balance it, we're going to add another hydrogen to the reactant side. This also means that we have to add another nitrate ion to the reactant side, since nitric acid is bonded together. We've now balanced the hydrogens, but this means that there is 1 more nitrate on the reactant side than on the product side. Fortunately, the nitrate is all by itself on the product side, so we can just add another one. We've now balanced the equation. So once we add a 2 next to our nitric acid and to our nitrate ion on the product side, we're done. 1b. Briefly explain why statues made of marble, calcium carbonate, displayed outdoors in urban areas are deteriorating. Marble, or calcium carbonate, has carbonate in it, which I earlier said always turns into carbon dioxide. This is because of something called bond enthalpy. The bond enthalpy of carbon dioxide and, in the case of marble, calcium oxide is much lower than that of calcium carbonate. Since the universe likes to conserve energy, the lower enthalpy bonds are more sustainable. This means that carbonate always turns into carbon dioxide and oxygen gas. This is unbalanced. Or, in the case of marble, carbonate will always turn into carbon dioxide and calcium oxide. Or, if carbonate is bonded to anything else, it'll turn into carbon dioxide and whatever is left.
This problem said, a solution containing silver 1 nitrate is mixed with a solution containing iron 2 sulfate. Determine the products and write a balanced reaction. The first step is to write out the reactants of the reaction, in this case AgNO3 and FeSO4. Then, use the polyatomic ion list and the periodic table to determine the charges. Next, using the solubility rules, we can determine that both silver nitrate and iron sulfate are aqueous. Because there are 2 ions in each formula unit of the reactants, this is a double replacement reaction, so we can write out the products. Now that the products have been determined, the ions and their charges must be balanced. Again, using the solubility rules, we now know the states of the products. The final step is to balance the overall equation. Because we have 2 Ags and 2 NO3s in the products, we must also have 2 AgNO3 in the reactants. Part B of the question said, if the products of the reaction were filtered, which substance would remain on the filter paper? The only substance that would remain would be the precipitate, silver sulfate, or Ag2SO4. We know this because this is the only solid left in the reaction. Everything else is aqueous.